Hello, in this video we're going to be looking at matrix inverses, or finding the inverse of matrices. This corresponds to section 6.2 in the book Finite Mathematics by Daniel P. Maki and Maynard Thompson. I'm not going to lie, I find this to be one of the hardest things in finite math. That doesn't mean it's impossible, but I think it's really hard because in this one you just kind of have to play with numbers. There's no this, then, kind of map to what you should do. You know what you should end up with, but there are literally a billion ways to solve every single problem, and I chose one that I think is challenging that you might see on a midterm or a final. I'd be kind of surprised if they do because it does take a little bit of time, but if you understand it, then you're going to be set for the rest of your finite career in terms of finding out matrix inverses. So why do we want a matrix inverse? Well, the first thing we should know is that you can't divide a matrix. It doesn't work like that. But what you can do is you can multiply a matrix by its inverse, and so the inverse of a matrix is just like the inverse of a number. And so if you have, let's see, you have the number 13, if you wanted to turn that into a 1, and that's what you're doing when you either divide something or you multiply it, you want to turn it into what's called its identity. You're going to multiply it by 1 over 13, right? Or you divide it by 13. So when you have a matrix, and I'm just going to draw a matrix and pretend it has stuff in it, you can't divide it by this, but you can multiply it by what's called its inverse, and so it's going to look kind of different, and it's got a -1 up there, and that symbolizes that is the thing that when you multiply it by the original here, it equals 1. So that's what we're trying to figure out here. As I said, I think it's one of the harder things to do. Before I get into the problem, I'm going to talk about the 3 different things you can do to matrices to kind of transform them and make this work. So the steps for finding out matrix inversion is to first write down your matrix, write down the identity matrix, and then use one of 3 methods over and over and over again, or any of the methods over and over and over again, to get the positions to swap. And I'll explain that bit in a moment, but there are 3 things we can do. So the first thing we can do is we can do row switching. And so that means if I have the matrix 1, 2, 3, 4, 7, 9, 12, 49, 15, you can swap any of these matrices around. So I could swap these 2 matrices around, or these 2 rows around, and all of this can only happen with rows. That's the first thing you should know. And so then you could get the matrix 4, 7, 9, 1, 2, 3, 12, 49, 15, and there's a mathematical reason for this. I'm going to say that I don't tend to use row switching very often because it's really easy to kind of back yourself in a corner and add a lot of extra work. So you can use this, I don't tend to use it. So let's look at the other 2 things you can do. The next thing you can do is called row addition, and this is really easy, and this is the one I tend to use the most. So if I have, I'm going to make this one easy, 0, 0, 1, and then I have 2, 3, 3, and 4, 5, 9. I'm just making stuff up. I could add this row onto that row, and I tend to write that out when I'm making my notes on what I'm doing like that. So I do an arrow on where I'm going to and what I'm doing. So if you were to do this, you would end up with a matrix 2, 3, 4, 2, 3, 3, 4, 5, 9. So all we've done, again, here is to add this row onto this row. And so you'll notice over here in the transform matrix, this is still the same. This one is different. This one we didn't touch, so ignore that one. But these are the 2 that, this is the one that changed, so we added. So that's what happened there. And then the final one is row multiplication. I think this is the easiest one, and I'm going to do this in the way that you're going to see it the most. So if I have 2, 0, 0, 1, 0, 1, 5, whatever, 10, I'm running out of matrices that I can make up. And it shouldn't be that hard, but it surprisingly is. I could multiply this row right here by 1/2 if I wanted to turn that 2 into a 1. And this is the thing you're going to use a lot. So if I were to do that, let's see, if I multiplied this whole row, I'd get 1, 0, 0, and then the other 2 rows don't change, right? I didn't do anything to them. So the first thing to be aware of is you only want to do one step at a time, and you only do it to one row at a time. You might use, like over here, you might use another row to do it. That's not what I wanted. I wanted a blue. You might use another row to do it, but that row doesn't change. Only one row changes at a time. And the exception to that is row switching. And honestly, I mean, it's kind of put in the same boat, but I don't tend to use it very often. And then number two, none of the rows are really changing. They're just kind of moving around. So those are the three things we're going to use for this one. And I'm going to clear our screen, and let's go ahead and get to the problem. And again, I think this one's challenging. It's not impossible, but we're going to go through it step by step, and I'm going to explain what I did and why I did it, and hopefully it will make sense. So let's get started with that. So I chose out of section, section 6.2, Matrix Inverses, in the book Finite Mathematics by Daniel P. Maki and Maynard Thompson. I chose one of the problems that one of our instructors had recommended, and they recommended a couple of different ones, and I chose one that I thought was kind of fun. It is problem number 23, and it's fun because it has an X in it. And you might be saying, that does not sound fun. But it's fun because it's probably about as hard as you're going to see on a test. They're not going to give you something much worse than this. This one is a bit of a pain, because if they made it too much worse, there's no way you'd have time to get it done. So things like this, it's good to practice these now when you have time. You can get comfortable with them. You know, as I said in the intro to this video, matrices and inverses of matrices are kind of hard because there's no set way to do this. I can't tell you do this, then do this. The only thing you can do is play with it. And so, you know, the plan is to do this one, and we're going to try to do a couple other videos that just kind of involve massaging these matrices around until they look like what we want. So the very first thing we're going to do is we're going to write down what the matrix is that we've gotten. So this is matrix A, and it is the matrix containing 1, -1, -1, -1, 3, and 2, and 2, -2, and x. So, you know, what's the first step? Well, the very first step, and I'm going to try to draw this so that we can see at least the previous step and the current step on each one, is to set this up with its, what did we call it? The identity matrix on the other side of this line. So let's go ahead and we're going to write down our matrix here. And unfortunately there's a lot of writing on this one. And then our identity matrix is 1, 0, 0, 0, 1, 0, and 0, 0, 1. And, you know, remember the goal here, I'm going to do a different color, is to swap so that this side has all these zeros and ones, and this side has a bunch of other stuff. And it'd be really nice if we could just swap, but unfortunately that's not the way these things work. So let's go ahead and figure out what our first step is. Well, when I first saw this problem, I thought that one thing I would like to do is I noticed that I had a 1, and when I have things that I notice, I'm going to try to do them in blue for you here. I noticed I have a 1 and a -1, and I have a 2 and a -2. And if I were to add those together, I would get some zeros, and so that's looking pretty darn sweet for that row right there. So what did I do? I took this row and I added it to that row. And this is just how I keep track of what I've done, because if you don't keep track, it's really easy to get confused, and we don't want that. So let's see, we didn't change the top row, right? And what else did we not change? Well, we didn't change the bottom row. Remember, for the most part, you're only changing one row at a time with this. And so, you know, there's a lot of steps, but if you take it slow, you're less likely to run into any problems. So 1 plus -1, well, that's 0. 3 plus -1 is 2. And -2 plus 2 is 0. And let's see, 0 plus 1 is 1. 1 plus 0 is 1, and 0. Okay, well, that seems pretty reasonable. And, you know, again, I'm looking at this row, and I want this to turn into our transformation matrix, which means I want this right here to turn into a 1, so I can multiply this whole row by 1/2, right? So again, we didn't change our top row. We didn't change our bottom row. and we did change this. So 0 times 1/2 is 0, 1/2 times 2 is 1, 0 times 1/2 is 0. Let's see, 1 times 1/2 is 1/2, 1 times 1/2 is 1/2, and 0 times 1/2 is 0. So that's where we end up after that. So where can we go next? Sometimes when you're doing these problems, you just got to take a moment and see what you want. And what I'd really like is to get this and turn it into a 1, while turning the rest of these into zeros. And you know, I'm looking at this and I'm realizing that if I multiplied this whole row by 2 and then subtracted this row from it, I could turn this into a 1 and I could turn this into a 0. So let's give it a shot. You know, sometimes you just got to try these crazy ideas and you don't have a lot of options. So, you know, what are we going to do? We're going to multiply this whole row by 2. So the first thing I do is, what's not changing? Well, your 0, 1, 0, 1/2, 1/2, and 0 is not changing. Your -1, 2, and x is not changing. Your 0, 0, 1 is not changing. But we are going to multiply that row by 2. And so let's see. We've got 2 times 1 is 2. -1 times 2 is -2, and 4, because 2 times 2 is 4. 2 times 1 is 2, and 2 times 0 is 0, 2 times 0 is 0. Okay, well now what I want to do, well, I want to take this row and I want to add it to that row. So, okay, let's, again, what are we going to do? We're going to write down the stuff that doesn't change first. And this is where I tend to make the most mistakes. Hopefully I won't fall into any of those traps here while we're doing this video. I will admit that I don't really do these in advance because I want you to see, you know, how somebody who is struggling through this math just like you is going to try to solve these problems. So hopefully this will be nice and clean and I won't make it too many mistakes. I always make some mistakes. So let's see. 2 plus -1 is 1. 2 plus -2 is 0. 4 plus x, I don't really like that one, but I guess we've got 4x. We're going to have to figure out how to get rid of that guy somehow. And let's see. 0 plus 2 is 2. 0 plus 0 is 0. 0 plus 1 is 1. Okay. So that's where we're at right now. Let's see what our next step is. Well, now, and you're going to laugh potentially, I want to turn this into a 0, right? And so the easiest way I can think of doing that is to take this and add it back down that way. You say, oh no, we just did this. And sometimes this is how you do these matrix problems. You redo the steps you've already done over and over again to get slightly different answers. So let's see, 2, 0, 1, and what I'm writing down are the things that haven't changed, right? If they haven't changed, we're not going to make any changes to them. And so 1 plus -1, well, that's 0. 0 plus 2, well, that's 2. 4 plus x, well, that's 4 plus 2x, right? 2 plus 0, well, that's 2. 0 plus 0, well, that's 0. 1 plus 1, well, that's 2. Okay, and so, you know, one thing I want you to realize is the stuff that happens over here, this is kind of secondary. We don't really, that is the matrix that we want, but we're ignoring that. Everything that we're doing is to turn this whole matrix over here into our transformation matrix. So as nasty as this gets, it's okay. We're just going to keep on keeping on, and hopefully it won't be too bad. So let's see, what's the next thing I could do? So looking at this, I'm trying to figure out what I want to do next. So let's see, I've gotten some things pretty tidy here on the bottom, and actually, you know, even though it looks kind of nasty, I think we can do this. So let's see. I think what I want to do is multiply this bottom bit by 1/2. Oops, I want to do that in blue. So let's see, we're going to write down, and the reason is I'm trying to get rid of these two different places where I have x's. I really don't like that, and so I think I can get rid of some x's by doing that. So let's see what we can do. So let's see, we're not going to change the top bit at this point. We're not going to change this. We're not going to change this. We're not going to change this. I mean, a lot of this is just rewriting stuff. And then let's see, we're going to multiply this whole bottom bit by 1/2. So 0 times 1/2 is 0. 2 times 1/2 is 1. 4x plus 2 times 1/2 is 2 plus x. I like that. And let's see, we get 1, 0, 1. Because multiply 2 by 1/2, you get 1, right? 0 times 1/2 is 0. 2 by 1/2 is 1. And now what I think I want to do, and this is where things get kind of tricky, just like you can add rows together, you can subtract rows together. So I am going to take, I'm going to do this slightly differently. We're going to multiply this row by -1. And, you know, normally I would just swoop in and do this, but, you know, if you get a little bit flustered, you can do things like this during a test, and you're just playing with the numbers. So let's keep on keeping on. 1, 0, 4x, because remember, my goal is to get rid of, see, I made my first of what I'm sure are many mistakes. I always make mistakes when I'm doing these. So let's see. So that's 4 plus x, 2, 0, 1. I haven't made any changes, so I'm just copying over the rows I haven't made changes. And I'm multiplying this whole bottom row by -1/2. And I don't want to do it that way. And I'm sorry, we're gonna step back. You know, if I do this, I have to add 2 more steps, so hopefully this will make sense. I can take a row and I can, instead of adding those 2 rows together, oops, I don't know why I just subtracted all of that. Instead of adding those 2 rows together, I can, let's see, 1, 2 plus x. I could subtract. I can take this row and subtract this row from it. So I'm gonna do this times -1, and it's like a plus. And so hopefully you'll see what I'm doing. It's a little bit hairy, and so hopefully it's not too bad. But I think this is the best way to do it. Sometimes you just gotta play. So, you know, if you can add 2 things together, that means you can subtract them, right? So that's all I'm doing here. So we're not changing this bottom row, and wow, I just want to erase stuff today. We're not changing this. So this is 1, 0, 1, 2 plus x, 1, 0, 1. And we're going to take this top row and we're going to subtract the bottom row from it. So 1 minus 0 is still 1. 0 minus 1 is -1. 4 plus x minus the quantity 2 plus x, which is the same as 4 minus 2, which is 2, plus x minus x, which is 0, so that just turns into 2. That got rid of my extra x. That's all we were doing there, right? And let's see. And then down here, 2 minus 1, well, that's 1, 0, 0. Well, okay. I can buy that. That seems legit. Let's keep on keeping on and see what happens, okay? So let's see, now that I've gotten rid of the x up there, what do I want to do? Well, again, I'm trying to get rid of these things that I'm adding back, and I want to get rid of this. I want to turn this into a 0. So if I add this to this, well, then I get rid of that. So let's go ahead and do that. So we've got 1, whoops. Let's write down the rows that aren't going to change. 0, 1, 0, 1/2, 1/2, 0, 1, 0, 1. 0, 1, 2 plus x. And let's do this math on the top one. Okay, so 0 plus 1, well, that's still 1. Let's see, 1 plus -1, well, that's 0. And 2, and we're getting there slowly but surely. Let's see, 1 plus 1/2, well, that's, I'm going to do this in fractions. 3 halves, 1/2 plus 0, that's 1/2, and 0 plus 0, that's 0. So that's pretty good. And let's see, what do I want to do next? Well, if I take this row and I subtract it from this row, so I'm going to write it like that. And so let's, what do? We write down the rows that aren't changing at all. So that's 1, 0, 2, 3 halves, 1 half, 0, and that's 0, 1, 0. That row, I'm loving that row because it's totally done. And this is kind of like how you want to solve this. You want to find the one row that you're totally done with, and you just want to use that one over and over and over again to figure out what's up. So let's see, we're going to subtract this. So 0 subtracted from 0 is nothing. 1 subtract 1, well, that's 0. And let's see, 2 plus x minus 0, well, that's still 2 plus x. And even though that's not quite where we want it, that's better than we were. So let's see, 1 minus 1 half, well, that's 1 half. 0 minus 1 half, well, that's negative 1 half. And 1 minus 0, well, that's 1. And so we're looking pretty good. We are pretty darn close. Doesn't seem like it. But what do I want to do? Well, I want to turn this into a 1. And so the way to do that is to multiply. And I'm going to scroll over so I have some room. I'm going to multiply this whole row by the inverse of 2 plus x. Or, how would you do, if you wanted to turn a 2 into a 1, you would multiply it by 1 over 2, right? So I'm going to multiply this by 1 over 2 plus x. And so let's see. See, what doesn't change? 1, 0, 2 doesn't change. 3 halves, 1 half, 0 doesn't change. Let's see, 0, 1, 0 doesn't change. 1 half, and 0 doesn't change. 0, 0, if you multiply those by 1 over 2 plus x, that doesn't change. 2 plus x, the quantity, times 1 over 2 plus x, well, that turns into 1. I love that. And then let's see, 1 half times 1 over 2 plus x, well, that turns into 1 over 2 times the quantity, 2 plus x. And actually, I'm going to go ahead and erase that because I'm going to run out of room. And I'm just going to do that math, which is 2 plus x times 2, well, that's 4. And, hey, this is something, we've seen this somewhere else, and we probably could have skipped around a little bit, but sometimes it's better to just go slow. This is negative, right? And then 1 over 2 plus x. And oops, I scrolled all the way down, didn't want to do that. It's getting kind of messy. Hopefully we can see it, and I'll try to write it a little neater next line. So we're almost there. I can see the home stretch. Okay, well, what do we want? Well, what we want is to turn this into a 0, right? We want to turn this stuff on the left into our identity matrix, and the stuff on the right is just going to be nasty, but we can't help that. So let's keep on keeping on. Let's see. Well, what I'd like to do is multiply, and again, I'm going to you can combine stuff together, and I've tried not to do that too much, but what I'm going to do is I'm going to multiply this row by 2, and I'm going to subtract it from that row. Gets a little messy, but it'll totally work. So, what are we going to do first? Well, first, we're going to clear up some room, because this is getting big and messy, and we're going to write down the rows that aren't going to change. So 0, 0, 1 doesn't change, 1 over 4 plus 2x doesn't change, 1 over 4 plus, I forgot, I don't have enough room. We're going to stretch out a little bit here. Hopefully I can fit it all on one screen. Let's see, 2x and 1 over 2 plus x, and this is one of the problems with matrices. They get gross and nasty pretty fast. You thought trees were bad. Matrices are the worst. Okay, let's see, 1 half, 1 half. Ooh, and this is a negative. See, I always end up making silly mistakes here. And so this is probably as big and nasty as you're ever going to see on a test. This is a really long problem. There's no way to make it too much cleaner. And so I really don't see you trying anything harder than this on a final or midterm. So if you can get comfortable with doing this, you're going to be in pretty good shape. So let's see. So if we were going to do that, we would do, let's see, 0 times 2, 1 minus 0, well, that's 0. 0 times 2, 1 minus 0, well, that's 0. 1 times 2, 2 minus 2, well, that's, ooh, hey, this is not a 0, this is 1 minus 0, and that's definitely 1. And then let's see, 1 times 2 and then 2 minus 2, well that's 0. And so now up here is where things get kind of nasty. So I'm going to try, I'm not sure the best way to do this. So let's see, 1 over 4 plus 2x times 2, well that's 1 over 2 plus x. And we're going to take 3 halves, I'm going to try to write it, minus 1 over 2 plus x, and then this one is 1 half plus 1 over 2 plus x, and then this is negative 1 over 2 plus x. Oh no, it's not. No. This is negative, and I could clean this up, but I'm not going to, because we are there. We don't care how nasty the stuff on the right is, because the stuff on the left is what we cared about cleaning up. And hey, look at this. This is our transformation matrix. We are done. So what did the question want? Well, the question wanted us to find some things in different positions, and let me see. It wanted us to find what's the thing in the position 2, 2. So what's the thing here? And that's, well, that's 1 half. You know, honestly, once you get this far, honestly, that's not the hard part. The hard part is doing all of this. So let's zoom out and talk about what we did really quick, and hopefully this will make some sense. So actually, I looked at the problem, and I think it's pretty useful. Part B does ask us, you know, what is the 2, 2 entry for the inverse of A, and that is 1 half. So we did have the answer there. But part A says, for what values does this inverse not exist? And this is what makes this such a fun, kind of interesting problem, and I'm going to do this in purple. So the values that this doesn't exist are situations where this is a problem. And so this is where that x comes into play. So for what values does 1 over 2 plus x not exist? When are there problems? Well, you know, the sci-fi nerds out there might have heard this whole you can't divide by 0, and that is a fundamental of math. You could never have a situation where you have 1 over 0, because things are not happy when that happens. So the answer to A is that any time for any of these, if x is ever negative 2, you know, we'll notice that things start exploding, and that's not good. So if x is negative 2, x can never equal negative 2 if we want this to exist. If x ever equals negative 2, this inverse is not possible. So, you know, now that I look at the question, I guess those are pretty useful, and this is the trickiest you're going to get. For what value does this inverse not exist? And they can only ask you that question if there are variables here. So if you see x's, that's the kind of stuff they're going to ask you. And the only time that's a problem here is if x is on the bottom, and since it is in all of our versions of x, it is when x is negative 2, because if we were to put negative 2 there, we would get 1 over 2 minus 2, and that would be 1 over 0, and that is very unhappy, as you can see by my frowny faces here. So let's scroll up and kind of talk about what we did, and, you know, holy cow, this is a huge math problem. So don't be afraid to try a bunch of these. They are not easy, they're not intuitive, you just have to play with them and kind of massage the data until you get what you want, and it's not easy. I wish I could just say do A, B, and C and then it's totally going to work, but I can't, unfortunately. So what do we do? Well, first we wrote down what we knew, which is what they gave us. Then we broke it up. We wrote our thing with its transformation matrix here on the right, because when you are trying to find inverses, this is how you do it. This is the formula. Then we used our 3 different steps, right? We used our the ability to move around rows. We used the ability to add rows. We're going to call it move, add rows to each other, and multiply rows by things. And sometimes we use these in conjunction. I really did not use this one, and I don't tend to use the move rows, but I tend to use this one a lot and this one a lot. And I really tend to use these two together. And you'll notice towards the end, that's really the easiest way to do this, because if you don't, yeah, a couple more steps, but if you got to do it step by step, it's okay. You'll still get there in the end. Just play with them. And so let's see, we started by doing some multiplying, then we did some more multiplying, and wow, it just got nastier and nastier. We added stuff together, And essentially we just played with the data over and over and over until we got this. And so they don't ask us explicitly, but let's go ahead and write it down. The inverse of the matrix A is the matrix. And I'm gonna try to have enough room that I can really draw this. 3 over 2 minus 1 over 2 plus x, 1/2, and 1 over 4 plus 2x. Now let's see the second part. The middle part is 1 over 2 plus 1 over 2 plus x, and then this is 1/2, and then this down here is -1 over 4 plus 2x. And then this final row is, I wrote the 0 first because I like that number. It's nice and easy to write, right? -2 over 2 plus x, and 1 over 2 plus x. And so we figured that out, and then for what values of x does this not exist? That was part A, and we figured out, okay, if we put a -2 in any of these, there is a 0 on the bottom of some division, and that's not okay. You could not divide by 0. And then part 2 was what is in this section right here, what is in position 2 of the inverse matrix, and the answer to that was 1/2. And pretty much that's our answer. So what did we do? We played around a lot. There's no other way to do these. Do some practice. We're going to try to get some other videos up that are some more practice so you can see what I think when I'm doing these, and just how I massage the data and how I play with them until I get an answer that makes some sense.